So today we are going to discuss an interesting topic of machine learning and then adversarial machine learning. I will try to cover this topic in the simplest way possible so that even if you do not have any background on machine learning, you will be able to understand it from the security perspective. So before we continue on this topic, any question about the minor exam answers or anything what we have covered in the previous lecture? Okay. Okay. First, I would like to give you a few examples, and then actually I will start talking about a little bit what machine learning is, because machine learning is so popular. Most of you already know what machine learning is, but still for those who do not have any background, so what you could think of is that if there is some characteristic which could be identified by a machine, and because of that human labor is reduced, then it is definitely desirable that we exploit the machine to do that task. So machine learning actually is very helpful in that task. So let me just first give you an example of what our doctors do. So when they look into the scan of the chest, and if they try to identify whether you are infected with COVID or not, then they look for some characteristics. And if they look for probably our image, I hope that none of us are infected currently. So they will see the images like these. But if there is someone whose chest or is infected, who is infected with COVID, then the chest scan will look something like this. So now what we could do is we could actually make a machine, an algorithm, learn about what is a normal X-ray scan and what is a scan which results into COVID. Okay, so which can be interpreted as COVID. So what the doctor is doing with his or her eye, we could do it with a machine. And once we actually make the machine learn to differentiate between the normal X-ray scan and the COVID X-ray scan, then if we give this machine an input that this is the image of the scan, tell me whether this is COVID or not. So the algorithm will probably tell us that, okay, this is COVID. Then if we give another scan, it has to choose between normal and the COVID. So probably it will choose normal. I don't know. I'm not a doctor, so I cannot differentiate these things. But the decisions will be made by the machine learning algorithm to between these. So machine learning algorithm will choose either normal or COVID. So let me give you a few more examples and then we can talk. So let's say you are given a task to or the machine learning algorithm this time is given a task to identify whether somebody is holding a gun or not. Okay, so if we see the image of a sheep and the image of a gun, so other than the color here, so if you just look into the structure of these two things, probably they might look a little similar. And that is why we need an intelligent machine learning algorithm, not just a dumb machine learning algorithm, which could actually differentiate between two items which may look to have the same structure, but they are two different things. So that machine learning algorithm, whatever we are trying to make that machine learn, it has to be very intelligent. It has to not look at the structure but also look at many more other features. So for instance, in this case, it would have been very easy to differentiate between these two if we are just looking at the color. So the color of the sheep here is white, the color of the gun here is black. So it would have been very easy for the machine learning algorithm if it is utilizing the color. Just a second. Yeah, sorry. Okay. So yes. So I was just saying that it is not just sufficient to have a machine learn about differentiating between two items based on the structure. It may also need to learn about the color and many other things. So now let's look into a much more complex environment. So what I'm trying to highlight here is that algorithm has to be very intelligent in order to work in real world environment. So if we are looking into an environment where that machine learning algorithm has to identify whether someone is an individual, a person, someone is a motorbike, or someone is or it is a car. So so you are just seeing this view from a camera which is installed on a traffic light or something, and that camera is taking this picture, and then the algorithm, whichever algorithm, machine learning algorithm is running, it is trying to differentiate between who is a person, who is a bike, and who is a and what is a car. Okay. So then now you see that the difference. So for us as humans, we could identify the small differences, but for a machine learning algorithm to identify those small differences, it is very difficult, and therefore the machine learning algorithm has to be much more intelligent. Okay, so now I'm going to talk about the terminology that we typically utilize in machine learning algorithm. But any quick question about the different examples that I gave? Okay. Okay. So hopefully, I guess you all know about machine learning. So, but let me just also continue with this basic set of definitions. So typically when we discuss an algorithm, a machine learning algorithm, we discuss that in two parts. So one is the learning phase where we are actually training that machine learning algorithm to identify whether something is a gun or something is a sheep, or as I showed you in the first example, whether something is a COVID infected scan or a normal scan, or something is a car or something is a bike. Okay, so we are just training that machine learning algorithm. And then in the operation phase, when you actually want that machine learning algorithm to tell you, given an input, that whether it is a COVID scan or a normal scan, and that is the second phase. So we have a learning phase and we have an operation phase. So the learning phase is called training, and then phase is called the test phase also. And the knowledge base that which is being trained, so the algorithm that we are utilizing, it must have some knowledge base, and that knowledge base we typically refer to as model. So so basically, if we consider all this terminology, so what we will say is that we initially train a model with a set of input output pairs, and then we go to this operation phase, and then we give the model an input and tell this model to give us an output. So this is the way we actually talk about. So this is so let me first also generally tell you about what would be the typical information flow in a machine learning algorithm. So you will start with some input. As I said, some data will be given, data of chest scans or data of so we also talked about intrusion detection system in the last class. So for instance, data of the network traffic data, the data corresponding to your system. So that will be the basic data that will be given to that machine learning algorithm. And then there has to be an intermediate step where we extract some features. So this is an algorithm. So this does not um, differentiate whether it is given something in the form of an image, if it is given something in the form of voice, or if it is given something in the form of network traffic. So an algorithm does not actually take these different formats. So you have to come up with an intermediate step, one processing step, which can take something which is common to everything, like an image, which is common to an image, which is common to a speech, which is common to a network traffic data. So all of them look very different. But what we try to do is we try to extract some features. So some properties. So the features could be something like a mean value of some data points, some variance value. So these are some of the terms that are very popular in statistics, and I hope that you understand those terms. So these could be some of the features related to the different variety of inputs that are possible. And then, so for instance, if we are looking into this image of the soldier, and we are trying to identify whether this soldier is carrying a gun or not carrying a gun. So the two class classifications. So we have to, so our model has to identify whether this soldier is carrying a gun or not. So then probably the way this image will be processed in order to extract features will be that we are trying to probably look into each pixel of this image, see what is the color of the pixel, and also try to see if a combination of some pixels are also leading to a structure which is like a gun. Okay, so those are some of the things that may be expected or that may be being processed by the machine learning algorithm, and therefore we need that intermediate step where we are trying to not only convert different types of inputs into one set of inputs, which are the features. So this feature set could be so this features could be in a very large number. So this could be just a set of two features, the mean and variance. So that will be a very simple machine learning algorithm, a mean of all pixels or variance of all pixels. But then you could go on to a very long set of features, and actually it is also possible that you directly start processing the input data as well. So rather than extracting the input data or converting the input data to a feature and then processing it using the machine learning algorithm, You can also have some very advanced algorithms which can just take each of the pixel of an image and then start processing that. So in that case, you could think of the set of features to be equivalent to each pixel in the image. So what I'm trying to highlight is that the set of features could be just one or two features like mean and variance, or it could be as large as possible. And you can think of an image like this. This could be a probably 600 cross 200 pixel image. So you could think of a feature set which contains RGB values for each of these pixels. So you can think of those many pixel values. Okay, so then you have an output label, and yeah, so the goal, the output label here could be the same thing that I have been talking about, whether this is a COVID infected scan or a normal scan, whether someone is carrying a gun or not carrying a gun, whether your intrusion detection system is looking at the traffic and it is detecting an attack or no attack. So this is the label, the output that we are expecting. So the intrusion detection system should tell me that, or the machine learning algorithm should tell me whether this is an attack or no attack. Okay, so any quick question about this terminology that we are using? Okay. Okay, so we will look into some of um, the ways in which this problem of developing a good machine learning algorithm was handled in the initial years, and then what kind of algorithms are typically utilized these days. Okay, so if you try to so I talked about two features, mean and variance. There could be many other features, but let's say that you utilized a feature one, and these just two features, and you have the value of feature one varying from let's say in this case -2 to probably 14, and the value of feature 2 varying from probably -4 to 4. Okay, so and then what you want to do is you want to see for each of the data points. So let's say for each of the image, what is so is there a way we could represent that data point on this plot? So what you could do is, so you'll take the data point, so for instance an image, compute some features. So in this case we are just computing two features, so let's say feature 1 and feature 2. So as I said, there will be an intermediate step. So I computed those two features, and now these two features actually represent that particular data point, and these two features may be slightly different um, for each of these images as well. And so you can so even if so if you are taking the X-ray scan of different people, it will look slightly different, and therefore these features might be different. So these data points that you see here, either the circles, the red circles, or the blue squares, so they just represent the values of these features plotted on this two-dimensional plot. Okay, so now that if we have already plotted, if we have put all these points on this scale of feature 1 and feature 2, then I also want to highlight here that there will be some COVID infected scans, some will be normal scans. So here you could clearly see that one set of data points are grouped together, and the other set of data points are grouped separately. They are also together, but they are just it is very easy to visibly differentiate between these two groups. And if we find that, so as I also said, there will be two phases, training and test phase. So if we have found that all these data points refer to the COVID infected scan, and all these data points, the blue ones, refer to a normal scan, and then we go ahead and train our machine learning model with all the data sets. Then with a new data point, hopefully that data point will again be very close to one of these clusters. So if a new data point comes during the operation phase, that machine learning algorithm will be able to easily identify whether it is COVID infected person or a normal person. So let me represent that with a cross. So if you get something, a data point which is close to this cluster, you identify that this is a COVID infected one. But if you get something which is near to this cluster, then you say that this is a normal person. Okay, so this is a very easy classification. So similar argument can be said about whether there is an attack or no attack. So if you have identified that some traffic features could be shown in this two-dimensional plot, and they represent this behavior that the attack, so whenever the system is under attack, these features represent the red cluster, and whenever the system is not under attack, the benign behavior is represented by the blue blue cluster here. And then you see one of those the data points. So you are analyzing the data traffic or your system in real time, and you identify that the current values lie very close to one of these clusters. So then it is very easy to identify whether there is an attack or no attack. Now, this does not have to have a very clear boundary as being shown here. It can also have a very different type of boundary. So rather than having a linear boundary, you can also have non-linear boundaries as well. So a very simple, other simple but slightly more complex than this linear boundary would be a circle. So if you see that all these red data points, they are within a circle, and all these blue data points are outside that circle. So even in this scenario, although this is slightly trickier than the first example, but here it is very easy for a machine learning algorithm to learn what is an attack, what is not an attack. Similarly, it is very easy for a machine learning algorithm to detect who is a COVID infected person, who is not a COVID infected person. Okay, but then things could be very tricky as well. So for instance, in this case, we are looking into 3 labels, so not just 2 labels. So 3 labels. So for instance, we are classifying not between COVID infected and normal, but probably something like so the so COVID serious, and then COVID non-serious. So COVID infected but non-serious person who could be sent to home, and then normal. Okay, so probably the Delta variant, so very serious one, and then Omicron, which is probably not very serious, and then you have this normal, it is fine. So we are trying to probably detect whether this person has been is very serious, seriously infected with COVID. If it is infected, this person is infected, but it is all right, not much damage has happened, and whether this person is normal. So we have to differentiate between these 3 labels now. So we are not just talking about 2 labels, but 3 labels. And then you start plotting 2 features, feature 1 and feature 2 as feature 1 or feature 2. And then you see all these data points here and there. So red ones, blue ones, and there is also these green ones. But now you see that there is no clear boundary that could be drawn to uh, identify one cluster. So identifying one cluster means here that if I try to draw a boundary to put together all these red dots or these red circles on this figure, it is not possible. There will always be some red circles which will be outside of that boundary, and therefore it is very difficult for a machine learning algorithm to learn um, uh, what are the features corresponding to somebody who is COVID infected or somebody who is COVID not serious and a normal person. Okay, so any question about these three different scenarios?
Sir, a small doubt. Sir, when in the case of an image, like suppose X at pixel XY, there is a color of the pixel. So these can be three features of the
Uh,
input.
uh,
Is it?
just uh, just a second, Ramita. Yeah, please go ahead.
Yeah, sir, I was just wondering, like, in case of an image, suppose there is a pixel at XY, like some location XY, there is a color of that pixel. So these are three inputs, like X, Y, and color will be the three features of the input.
Um, no, so can you please repeat?
There is an image
Mhm,
where there is a color at position X comma Y. That XY is the pixel location, and the
mhm,
color is the color of the pixel actually. So
mhm,
these are three features of the like input. These are called three features.
hmm. Yeah, that's an interesting question. So, okay. So we can consider them as three features. So the thing is that you have to first identify what features you are going to use. Okay, so definitely if you think about an image, you can probably think about, okay, so x coordinate or y coordinate and then the pixel color. So probably I could take all these three as three different features. So that is definitely possible. Um, so typically, that is not how things are done, but I guess it is also possible to consider all three of them as features. So there is nothing wrong in it. So it's just that whether considering those features will give you the correct output or not. So your machine learning algorithm will learn correctly or not. So I think if you even if you use only those three features, the learning algorithm will learn about it in very decently, so it will not be too bad. So the thing is that you think about this image. So I will tell you what can go wrong if you just consider only those three things. So if you take an image when my face is in the middle of the screen, and you take an image when my face is probably on one of the sides of the um, uh, image. Okay, so just considering the color or just considering the xy coordinate probably is not good enough to identify whether I am in this image or not. Okay, so if you are making a decision whether I am in this image or not, my face is in this image or not, probably just having those three features would not be enough, because my face could be here and there, and yeah, the color, background color could also match my face, so those things could be there. But yes, these three could be features.
So what if this is not the correct way? Then what is the correct way actually?
So this is a very, very good question. So people have looked into it for years, and that is how these machine learning algorithms have developed. But I would also add to that that people developed very interesting, very complex algorithms to identify. Let's say we are just talking about this facial recognition. So people actually started identifying what are some of the boundaries that we could identify. So can we identify edges? So where there is some difference. So whenever there is a face, there is some continuity, but when the face ends and some other object starts, so there is always an edge. So can we identify that edge and all those things? So people developed very complex algorithms to detect, let's say, the face or any something in any image. But then in the recent decade, people have come up with algorithms which do not, so people do not understand how those algorithms work. But basically what you do is you just give them these images. So let's say it is identifying the faces. So it actually learns the what features it has to extract by itself. You are not telling it what it needs to learn, and then it exploits the whatever features are there in that image, the pixel values, and then the look, definitely it is also looking at the pixel location as well, but all of that is inherently taken care of by that algorithm, and it gives a very high accuracy as well. Okay, so let me first, I will try to give you a concrete example. Probably that is not a concrete example, so let me try to give you a concrete example. So what is a feature? Okay, so let me show you this slide. Okay. Okay, so let's talk about network intrusion detection. Okay, that is what we have been talking about. Okay, so what we try to collect is traffic data. Okay, so it could be an attack network traffic data, or it could be benign traffic data as well. Okay, so what you do is you just collect data, you are sniffing packets, and then you do some kind of pre-processing. So as I said, you need to extract some features out of it. Okay, so in this case, what kind of features we are looking at are only present in the packet header. So if the data is encrypted, of course, there is nothing much that you could do or you could make out of an encrypted part of the packet. So the parts which are not encrypted, for instance, headers and the flow metadata. So for instance, if a packet is transmitted at t is equals to 1 second, then the second packet is transmitted at t is equals to 2 second. So the inter packet difference is 1 second. So that is also flow metadata that we are looking at. So the difference between different packets that are being communicated is 1 second. So then that becomes one feature, that so inter packet time or interval becomes one feature. Okay, so that could become one feature one. Then the feature two could be destination. So which is the destination of the packets. So let's say, so we could identify the destination probably by looking at the header. If probably this is not the, if the that part is also not encrypted, but hopefully it is not encrypted, and we can look into the packet header and figure out what is the destination. So if the destination, so we know, and we also identify whether some destination, so we also need to probably identify what type of destinations you are looking at. So you are not just through the machine learning algorithm, you will not probably directly feed the IP address. So you will feed something like whether this destination is within India, or whether this destination is outside India, something like that. So if you know that no packet should have gone outside India, so from your system, then this feature would be very, very important for you to identify whether there is a packet or not, whether this packet is probably um, uh, coming from an attack traffic or a benign traffic. So let's say if it is the distance from your current location. Okay, so probably you did not identify between within India and outside India, but probably there is a way for you to calculate the distance. So probably you are also looking into a feature 3, and you know that this packet has been sent in response to some other ping, so you could look into the ping traffic and probably figure out how much distance is between the source and the destination. So you are trying to also estimate that, so that could become a feature 3, the distance between the source and destination. And you are trying to see that, okay, now if I could see this distance, I could make something out of, I could differentiate between attack and non-attack. So now if you're looking into this distance, that distance could be analog, so it could be 5 meters or 5.1 meter or 5.2 meters, so that could or kilometers, or 500 kilometers, so that could be an analog value, and therefore you could plot it on a 2D plot. So what is the, whatever is the distance. And similarly this feature 1, the inter packet timing, that could also be analog, so it could be 1 second or 1 point, or probably 1 millisecond or 1.1 millisecond. So again, that is also another analog value. So those two could be analog. So feature 1, feature 3 here could be analog. Feature 2, what I said, whether this destination is within India, outside India, that is something that could be a digital um, a feature as well. So just two values, not more than two values. So all these different kinds of things could be features. Okay, so the features could be anything. It's just that whether that, so we have to identify whether that feature will actually help us in reaching to a good decision making algorithm or not. Okay.
Right, sir.
Right. Okay. Okay, so since I am on this slide, let me just complete this slide as well. So we were talking about images. So let's say that the goal of the algorithm is to figure out whether, so this is an algorithm which is fitted on an autonomous vehicle, and it has to identify the traffic signs on the sides of the road and then follow those traffic signs. Okay, so this is an autonomous vehicle. So if we look into the traffic sign, figure out whether it is a speed value that is written on that traffic sign, or whether it is a stop sign, whether it is something related to U-turn. So all that has to be identified by that autonomous vehicle. So what it will do is it will probably use the camera, capture the image, do some pre-processing. Um, so it will extract some features out of it. So without going into too much detail about again those features, so then it will use some model. As I've been saying, there has to be some knowledge base which has to be trained, and then that if that model has already been trained, then you are just using that model to figure out what is, so you are not probably directly telling what is the output. So you are saying that it could be a speed sign, probably, but the probability that it is a 5 is 60%, probability that it is a 9 is 20%, something like that. So you are not actually telling whether it is a 5 or 9, and then based on that you are taking a decision. So you are, so if it is so you are going at 15 kilometer per hour and the sign says 30, so you have to engage a brake, so you take a decision based on that. So that is also something where this machine learning algorithms play an important role. And then another a very generic um, example will be this flow chain that I have also explained earlier. So you see that there will be something in the physical domain. So for any machine learning algorithm, this is true. So there will be something in the physical domain. There will be, then you will have to bring it in the digital domain. And then you will have to actually utilize a machine learning model. And for that, you have to do pre-processing because these models are generic. The same model could be utilized for computer vision, and the same model could be utilized for network intrusion detection. So you have to do some pre-processing to use these models, and then you get back to the physical domain, probably do some action. So the decision will actually result, the decision of the machine learning model will actually again result back to the physical domain. Okay, so any quick question about this, how these machine learning models play an important role in a variety of scenarios? Okay. Okay, so let me just put out some names of these machine learning algorithms. So nearest neighbors is a very simple ML algorithm. It just looks for clusters and figures out whether some data point is close to a cluster or not close to a cluster. Then some advanced ones that were, as I said, very complex machine learning algorithms were developed, which had sound mathematical backup. So they were so some of them so one of them is a support vector machine. So it has sound mathematical base on which it works. Then there could be a simple decision tree as well. So a decision tree will be whether this pixel value is uh, let's say red or a blue. So so based on then if it is red, then again you make a decision whether a pixel value is uh, dark red or light red. So this is just a set of decisions that you are making, and then probably based on this tree you reach to some conclusion. So this is also some of the uh, ML algorithms which showed that you do not need very strong mathematical backup to learn effectively and give out very robust decisions. And then people actually started trying something very unique, that rather than depending on mathematics, rather than depending on this idea of doing nice processing, extracting nice features, we just feed the digital domain image or anything in the digital domain to an algorithm, and then let's see what happens. And people figured that that can also work in many scenarios. So these examples of artificial neural networks and deep learning, so these are some of those algorithms which take inputs without too much um, understanding about what those the features could be, which could be actually helpful in correctly identifying there. So for instance, in decision tree you have to probably figure out what will be the thresholds at which you have to make a left go to the left leaf or the right leaf. But in deep learning you don't worry too much about those thresholds or something. You allow the machine learning model to learn those thresholds on its own. Okay, and so the frontier research that is from our perspective, uh, who are looking into security issues in this topic, are identifying malware. So of course, intrusion detection systems has been something which has been there for a very long time, and malware detection is one of the important problems there. And then these days, biometrics has also been utilized in many security sensitive scenarios. So our Aadhaar card identification is actually based on biometrics. Door lock and unlocks, they are based on biometrics. So they also utilize some kind of learning algorithms. Face recognition based decisions are very popular these days. Of course, the next generation self-driving cars, they will utilize machine learning in a very big way. And unmanned air vehicles, drones, they are already using it, and they are also going to use some ML algorithms. Okay, so can anyone tell me some more frontier research where you see that a learning algorithm will be utilized and it will be security sensitive? So which I have probably not mentioned here.
Maybe some
Maybe some
vulnerability
vulnerability
analysis,
and analysis.
static source code analysis tools are starting to incorporate ML for
Yes.
detection of vulnerability.
Yes. So Code analysis. Okay. Okay. So that is fine. So what is the goal of that code analysis? That
To basically uh, reduce the number of false positives, because static code analysis produces so many false positives. So to
yeah. So for what? So what are you trying to detect after doing that code
bug
analysis?
security vulnerabilities, bugs in the code.
Yes, so bugs in the code. Yeah, good. Very nice. Okay. Anyone else? Okay. So now we come to the interesting part. So that was a long introduction about ML, but I think it was needed to understand where does this adversarial ML play the role. Okay, so we talked about two phases. So we first said that there will be a knowledge base, which will be the model, and then we talked about that there will be two phases. So one will be the training phase, and then one will be the test or operation phase. Okay, so you will start with you will have this model, and then you will have a lot of data points. So data 1, data 2, and points like this, and then this model will be trained with these data points. Okay, and then this model will be stored somewhere. So a stored model, and whenever in the operation phase, whenever a new data uh, comes, so let's say some data 101, then this data 101 will be fed to this model, and this model will give us an output. So for instance, if we are talking about an intrusion detection system, so this intrusion detection system will be trained with the what is a benign behavior, what is an anomalous behavior, and it will be given a variety of data points corresponding to benign behavior. It will be given a variety of data points corresponding to anomalous behavior, and now this model is trained. So now this model is put in your system, and now it is actually monitoring the traffic in real time, and it is creating those data points, feeding it to the model, and identifying whether this is an activity which is whether this is an anomalous activity or not. Okay, so this is the operation phase, and now we have a training phase. Now what an adversary now, so this the adversarial ML has been in this research domain for around 5 to 8 years. Okay, so what people have been doing is targeting these different steps. Okay, so we have a training phase, we have a stored model, and we have an operation phase. So the very overarching area of adversarial ML has been to actually target these different components of the machine learning algorithm by different techniques. Okay, so you could target any of these three things. So let me first start with a very simple one. So let's say you have stored a model. So let's say Facebook has invested millions of dollars. It has collected a lot of faces from users, and it has trained a model to correctly identify users. So if you upload an image, it will be correctly identify who it is. So if it is me or it is you. Now that model is stored somewhere on some server. So what an adversary could do to target this model would be to do something which is called model stealing. So if I could figure out, so let's say it is a machine learning model which is utilizing these 10 features. Okay, so feature 1 to feature 10, and then it is probably utilizing this nearest neighbor. So I told you that nearest neighbor is one of the machine learning algorithm. So let's say it is utilizing nearest neighbor algorithm, and the some of the training data that has been utilized to train this model are these data points. So this is a lot of information. So what are the features that are being utilized, what algorithm has been utilized, and what are some of the training data points that has been utilized. So all of that information is actually related to the stored model. And if someone could steal that model just by using some adversarial technique, then this millions of dollars of investment that Facebook has done, that to develop that model is probably lost. So the advantage of Facebook in doing in investing such money will be lost. So that so this model stealing probably is one of the simplest, although difficult, but one of the simplest adversarial ML techniques. So where what you are trying to do, you are trying to extract the information about the model that is being utilized. So once you, so let's say I want to start a new company to do facial recognition. So what I will do is I will just go ahead, steal the model that Facebook has developed, and that will be my starting point. And then I will try to improve the model and probably try to do better than Facebook. And that is how I will try to um, put up my start my startup. So that would be a very nice way to do a startup. So that is the very one of the easiest way of attacking a model. So any question about this one aspect of adversarial ML, this model stealing attack?
So this stored model means it's stored in the hard disk of some system, right?
Yes, it is stored somewhere. In the case of Facebook, let's say it is stored on some cloud server.
So it is like still similar to other like viruses or something which steal data
Yes, so
from
that's
the
a good
system.
question. Yeah, no, this is different. So this is a good question. So how do you do this model stealing? Okay, so that is something that you asked. So there are different ways of doing model stealing. One of the ways would be that you know you have access to the model. Okay, so the attacker has access to the model, so we have access to the Facebook's model, because if we upload an image, the Facebook will actually run that model and tell me whether it is my face or my friend's face, something like that. So that is called a black box access to the model, or let's just say that there is you have access to the model in such a way that if you give it an input, it will give you back an output. So if so you can give some input and it will give you some output. Okay, so you have this type of access, so you can always give this input to it and you will see the output. So now what you could do is you could give it thousands, millions of inputs and see the output. And after doing the analysis of these outputs, you will try to see what is the model about. So what algorithm is being utilized, what features are being utilized, what is the training data that has been utilized. So this is the way you will try to steal the model. So this is not like getting bypass the security features of authentication or authorization and access control and then stealing the information. It is like, so you have the model access. So Facebook gives you the model access. Many machine learning algorithms or which are being utilized by different enterprises, they give you this access. So then this is what you can do. So give it input, take out the output and do the output analysis to figure out what the model is. So you see the difference between this model stealing and then the other security issues that we have been talking about.
Right, sir.
Okay. Okay, so this is the one of the simplest, although difficult, but one of the easiest attack to understand. Then we have attacks during the operation phase. Okay, so one of the simplest attack during the operation phase is that you have the model, but what you do is what the attacker does is it crafts a data point. Okay, so it crafts a data point in such a way that the model gives a wrong output. Okay, so the goal here for the attacker is that it has to craft a data in such a way that the output is wrong. So for instance, yeah, so let me just give you this example here. Okay, so although our machine learning model may be working perfectly fine in benign environment, but what the attacker could do is, so this is a stop sign, this is a traffic light, so this is a traffic sign which is popular in other countries. I don't know if in India we have this hexagonal shape for a stop sign or not, but yeah, so this is in definitely in US, a hexagonal shape with a stop written and the color is red. So the machine learning algorithm would have learned that this should be the stop sign. But if somebody puts some simple words on top of it, it sticks some of these words, then the ML algorithm will start. Let's say the ML algorithm stops or this, so it should have identified this as a stop sign, but after putting these letters, it stops identifying it as a stop sign, but it, let's say, identifies it as something else. Probably let's for we are not giving any other example, so let's say that it is not a stop sign, but it is something, some other traffic sign. Okay, so probably a sign related to speed. Okay, so it stops identifying it as a stop sign, and if it does not identify it as a stop sign, then the car will not stop, and that could lead to accidents. So you see that the model was fine, the model would have worked fine in normal scenarios, but what the attacker did was it did something with the data that is going to be fed to the algorithm in the physical domain. So this is not that it is playing in the digital domain. In the physical domain, it did something, and the image was taken by the, let's say, car's camera, and then the algorithm processed this image and figured that this is not a stop sign. Okay, so any so this is what I said about the attack on the operation phase. Attacker crafts a data in such a way that the model gives a wrong output. So any question about the attack during the operation phase?
Sir, the model stealing itself will be a machine learning process, right? I
Yes,
mean, it will try to learn the model
yes,
based on the input and output.
yes, yes. So these, so that is what I'm saying. This adversarial ML is a completely different area of security, where we are not talking about the conventional cryptographic primitives, the conventional idea of um, using these permutation combination in order to prevent the or provide security properties like confidentiality, authenticity. So this is a completely different area where machine learning is being utilized, and then people have come up with what can go wrong in these machine learning algorithms when they are utilized in real world environment.
And only after we steal the model, we can actually modify the input for our attack purpose, right? Or
No, 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 no.
is
So
there
these
any
two are two
dependency?
different attacks. So these two are two different attacks. Okay,
Okay.
so let me just give you an example that let me also give you another example. Yeah. So yeah, so deception. So for instance, this is the face of this person, and what she did was she, if this face was uploaded on Facebook, the Facebook would have identified the person correctly. But what she did was she wore some glasses, and then uploaded the her image on Facebook, and then the Facebook actually identified this person as someone else. So this is the person. So the algorithm that is running, it is trying to identify what is the, let's say, what is the name of the person who is in the image. Okay, so if that is the goal, so if this person would have just directly uploaded her image, she would have been clearly identified. But what she did was she wore some glasses with some pattern, specific pattern, and then the resultant was the name of the person which was popped out from that image after running the algorithm was related to this actress. So this is the attack that I'm saying. So this is the second attack that I've been talking about. So you are trying to so that is the model stealing was the first attack. So we concluded our discussion about model stealing. Now I am talking about the other attack. So crafting a data so that the output is a wrong output. So this can be done even without stealing the model.
Okay, sir.
Okay, so we are out of time. So we have another. So let me just say. So this is so one attack was on directly on the model, stored model. The second attack was during the operation phase, where the attacker is crafting data and then getting out the wrong output. But the third attack is something on the training phase as well. So this is called training set poisoning attack. So here, what you are trying to do is, while this model is being trained, you try to induce some malicious data. So let's say this. Let me also show you here. So if the the algorithm is learning about a variety, whether something is an attack or not, then what you are trying to do is you are trying to affect its learning accuracy by actually launching an attack or making sure that the algorithm actually learns wrongly. So let me just give you an example from intrusion detection system. So if an intrusion detection system is learning about what is a benign behavior and what is an anomalous behavior, then training set poisoning says that the attacker will try to make the model learn that although something is an anomalous behavior, it is actually a benign. It is learned as a benign behavior. So something actually is an anomalous behavior, but is learned as a benign behavior. So let's say if the feature 1 is greater than 10, then it should have been a benign behavior. If it is less than 10, it should have been anomalous behavior, so that the model should have learned. But if uh, the model gets a data point saying that no, so the feature of the feature 1 is greater than 10 even for the anomalous behavior, then this model will probably look for another threshold to define between what is an anomalous behavior and what is a benign behavior. So we will talk about this training set poisoning attack uh, again in the next class. Probably it might be more clear, but what I'm just trying to highlight here is that there are different phases in a machine learning algorithm. So training phase and operation phase, and there is also a place where the model is being stored, and then there are variety of attacks that could be launched on these variety of phases or the model itself, and they actually lead to probably different outcomes as well. So in the case of model stealing, the model is stolen. In the case of wrong output, the algorithm gives out a wrong output. In terms of training set poisoning attack, the model itself actually learns something which it should not have learned. Um, so we will talk about training set poisoning again and continue our discussion on what could be some of the ways to prevent this adversarial ML attacks as well. Okay, so any question about what we discussed today? Okay, so let's talk again tomorrow. Bye bye.